Well, here they're asking write the following in decimal form and say what kind of decimal expansion each has. Look at the first one. It's 36 by 100. Well, it's quite easy, right? You can write this as 0.36. The decimal expansion terminates after two decimal places. So we can also add that the decimal expansion is terminating and hence it's a rational number. Well, what if the decimal expansion does not terminate? Look at the second one, which is 1 upon 11. Look at the denominator, which is a prime number. Okay, so remember this is a quite important or I would like to point out quite an important form of rational number where the denominator is a prime number and the numerator is always a 1. So if you compare it with the standard form p by q, p happens to be 1 and the denominator q is any prime number. This quantity 1 upon a prime number, just remember it, because we're gonna have this proof later in the class 10. The thing is that 1 upon any prime number apart from 2 and 5. So if there is any prime number in the denominator apart from 2 and 5, this quantity will always have a decimal expansion which will never terminate. Okay, and it will always be a recurring non-terminating decimal expansion. Let me write that here for you. Recurring and non-terminating. So you may jot it down. And we also know that recurring and non-terminating decimal expansion are those for rational numbers. Yes, exactly. So by the way, what is 1 upon 11? 1 upon 11 is basically, let me write that here for you, it is 0.0909909 and it continues like this. So you would see here that 09, this block of 2 digit keeps on recurring, right? So we may also write this in short as 0.09 bar. There you go. Okay, and what about the third one? 4 is to 1 upon 8. Well, this is a mixed fractional form, so you can write this as, you may write this as 33 upon 8, right? Okay, so this has a decimal expansion which is terminating, and if you would calculate it using long division, you would get 8 4s are 32 with a carry 1, then 1s are 8, then you have 20, then you can write 2s are 16, you have 4, then 5s are 40, 4.125. So the decimal expansion terminates after 3 decimal places. Therefore we can say 33 upon 8 is a rational number. Look for the fourth one, 3 upon 13. And yes, what do you see? 3 upon 13. Check out the denominator. It's a prime number, right? Yes. And also the numerator and the denominator are, you can say they are co-primes. That is, they are relatively prime to each other, right? So this kind of format is also quite an important one, and the decimal expansion for the following will also guys not terminate, and also it will be recurring. So let me write that here for you. You may perform it using the long division. Okay, so you will get 0.2307669. Okay, you will have this block repeating itself this block which has how many digits? 1 2 3 4 5 6, 6 digits, which are 2307669. So if I just write that in the decimal expansion form, you will have 0.230769, 2307669, and so on. It will continue like this, with this block repeating itself. Okay, I hope you got that. Okay, and let's look at the fifth one, which is 2 upon 11. Well, you can easily relate this with the second example that we discussed here, the second problem, 1 upon 11. So basically this one here is nothing but 2 times of 1 upon 11. We know that 1 upon 11 that we got is 0.09 bar. So basically if you multiply this by 2, what would you get? Yes, you are correct, you will get 0.18 bar. So now the block of digit, the two block of digits which are repeating is 18. So it will be like 0.181818 and so on. It will keep on repeating 18 infinitely. And let's look at the last one. We have 329 divided by 400. Okay, well, it's easier that you split or express 4, which is in the denominator, sorry, the 400 which is in the denominator, as 4 into 100. If you just look at this, you may write 329 divided by 4 as 8s are, okay, that will be 32, and then you're gonna have 2s are 8, right? Then you will have point, then again 2s are 8, then 5s are, right? So if you divide this by 100, or in other words multiplied by 1 upon 100, you will get 0.8225. And as you can see, the decimal expansion terminates after 4 places of decimal. So yes, it's a rational number, obviously. I hope you got all these 6 of the following decimal expansions.